Alright, hi guys, it's Miss Thorn. Thought I'd do a quick video wrap up for your molar ratio part 1 worksheet. I fielded a lot of questions today, mostly they had to do with number 8, which was looking at not only the molar ratios, but comparing masses when you're looking at a chemical equation. And there's some significant differences in between finding a molar ratio and finding a mass ratio. So I'm going to highlight some of those differences here for you. When you're looking at a molar ratio, so the first set of problems should have been pretty much a review of what you did in the edible stoichiometry lesson. You were looking at the equation, paying attention to the coefficients. For example, if you're creating water, your reaction is O2 plus 2H2 yields or produces 2H2O. And so if you just were to draw that out, it would look something like this. Okay, where the coefficients are actually telling you how many molecules or particles you have of each thing. And remember, if there's nothing written, you assume it to be 1. So our overall ratio of reactants to products would be 1 molecule of oxygen, O2, reacts with 2 molecules of H2 to yield 2 molecules of H2O. And now you can take this ratio and scale it up to different numbers. Like if you had 10 O2s, you would react with 20 H2s to produce 20 water molecules. And that can be scaled up all the way to 1 mole, to 2 moles, to 2 moles. So I hope that that was your key takeaway from the first part of the lesson. Okay, so when you look at mass comparisons, finding mass ratios, you can no longer rely on the coefficients, the straight up coefficients, to tell you the ratio. Why is that? Well, you wouldn't expect to say you were given 10 grams of oxygen. Well, you can't look at the ratios 1 to 2 and assume that that means you'll need 20 grams of H2 to react. That's not true, because these 2 molecules have different molar masses. And if you don't remember what that is, it would be probably a good idea for you to check out some of the tutorials of Mr. Bryant's that I've posted before. Real quick review: molar mass of oxygen. Each atom of oxygen has a mass of 16 atomic mass units, but you have 2 of them, so O2 has an atomic mass of 32, which means for every 1 mole, you'll have 32 grams. Okay? For hydrogen, hydrogen is super light. The atomic mass of hydrogen on the periodic table is 1.01. So if you were to find the molar mass of H2, that would just be 1.01 times 2, 2.02 grams per mole. Something that's super light and something that's a lot heavier is going to affect what your mass ratio would be. So when you do mass ratio comparisons, you're going to need to know the molar masses of the substances you're looking at. You need to use that and your coefficients from the balanced equation, and you need to do the multi-step problem by using your best friend, dimensional analysis. So some tips for success I have for you. Write it out. Write out the equation. Show your work. Write out your steps. Always, always, always include your units because they will guide you. Use them as a guide for when you set up your dimensional analysis. Because if you look at what units you want to cancel out, that tells you what belongs in the numerator and what belongs in the denominator. All right, so if you look quickly at this equation, this is the equation you're given in your worksheet. To find the molar ratio, all you have to do is look at the coefficients that you're given. So remember, if there's nothing listed, you assume that coefficient to be 1. So overall, again, So your overall molar ratio is 1 to 3 to 2. All right, real quick, if you had to draw a picture of what this equation is telling you, using some different colored shapes, purple represents nitrogen, so I have 1 molecule of N2, and because it's 1 molecule, those 2 things have to be bonded together. I have 3 molecules of H2, so 3 individual molecules of each consisting of 2 hydrogen atoms bonded together. It would be incorrect to do it like this. That's actually H6, 6 atoms bonded together. This is telling us 3 individual molecules, each molecule consisting of 2 hydrogen atoms bonded together. And so you've got 2 NH3 as a product. Okay, so what else can we read from this equation? Well, I can definitely say that 1 molecule of N2 will react with 3 molecules of H2 to produce 2 molecules of NH3, okay? An equivalent statement would be, if you were to scale that up times 6.022 times 10 to the 23rd, would be to say 1 mole of N2 will react with 3 moles of H2 to produce 2 moles of NH3. And those 2 statements are equal. They are equivalent. Why is that? Well, the reaction can only occur in its simplest form in that whole number ratio. So you can scale it up as much as you want, but it will always, always, always reduce to that combination because you're never going to get halves and quarters of things combining. It's always going to combine in a whole number ratio. All right, so we've established that we have this ratio of 1 mole plus 3 moles makes 2 moles. What we need to figure out next is what would be the mass of each thing in grams? And it's not as easy as just taking whatever N2 is and multiplying by 3 or multiplying by 2. You actually have to look at each individual substance and its molar mass. Okay, so let's start here with nitrogen. So nitrogen exists as N2. It's a diatomic molecule. If I look in my periodic table and find nitrogen, its atomic mass is 14.01, and technically that is saying atomic mass units, or AMU. To find N2 though, to find its molar mass, because we have 2 atoms, we need to take that number and multiply by 2, which would leave us with 28.02. Well, what does this number mean? It means that every 1 mole of N2 has a mass of 28.02 grams. So the molar mass of N2 is 28.02 grams per mole. Per 1 mole. Every 1 mole weighs this many grams. So over here, look, we've only have 1 mole. So all we need is 28.02 grams. If I needed 2 moles, I would have to take this number and multiply by 2, but I don't, I've got 1. So the dimensional analysis actually looks like this. 28.02 grams per every 1 mole times, well, we only want 1, equals, these things cancel out, and that's what you're left with. Okay, so that answers the first part. I think now using this information you should be able to go through and do H2 and NH3. Right now I'm just going to tell you it would be incorrect to take this mass and multiply by 3 to get this and to get this. Remember, you need to do the extra step of finding the molar mass first for each substance because each substance has a different molar mass. You can't just assume that it's going to be the exact ratio that you found for molar ratios. Okay, really quick, let's look at H2. So if you have hydrogen on the periodic table, it has an atomic mass of 1.01. We want to know though what the mass is for our molecule H2. We have 2 atoms of hydrogen, so we're going to take that mass and multiply by 2 to get 2.02. So our molar mass of hydrogen is 2.02 grams per mole, which you can abbreviate MOL. Okay, so again, if you recall, the molar mass for N2 was 28 grams per mole. So hydrogen is significantly lighter. That's why you're going to find that our mass is a lot smaller for this category. So I need to know how many grams I have if I have 3 moles. So let's do the DA real quick. If I have 2.02 grams for every mole, and I have 3 moles, then I have 6.06 grams. So if you were measuring things in a lab, you'd find that 28.02 grams of nitrogen would react with 6.06 grams of hydrogen exactly to produce ammonia.